Assalamu alaikum. In this week's lecture, we are going to discuss object-oriented programming features in Python. So we'll start the chapter by discussing object-oriented programming, what it means, and how can we implement it in Python. So we'll start by discussing classes, how can we define them, how can we create objects of those classes, and then what if we have multiple classes? What are the kind of relationships that we can create between them? We'll discuss inheritance, then composition, association, and finally we'll end with aggregation. So we'll discuss each of these individually and then we'll compare between those four types. Finally, we'll end this week's lecture by discussing abstract classes, and then next week we'll continue with object-oriented programming features, including polymorphism, the differences between static and instance variables and methods, and regular expressions. So first of all, what is object-oriented programming? As you've studied in Java, object-oriented programming is one of the four main paradigms of programming. It views entities of the real world as objects. And every object is an instance of a class, such that a class is thought of as a template or a blueprint that contains the definition of all the features of this entity in the real world and all of the behaviors of that entity, where features are defined in variables and behaviors are defined by methods. So an object is just an instance of a class that includes some actual data. So, for example, a real-life entity is a car. So we can define a car in object-oriented programming in Python as a class, where it has some attributes and also has some methods. So some of the real-life attributes of this entity is that every car has a, for example, manufacturer. A car has a year of creation. A car has a model. And it also has some behaviors. We can drive a car, we can drive in reverse, we can also brake. So this is the definition. When we define those as methods in a class, we can now create objects of those class, meaning we can create some actual examples of different cars. So each object is a specific type of car. So for example, the first object can be for example, car 1, where this car has its own model, it has its own manufacturer, it has its own year of creation, where car 2 has different set of manufacturer, model, and year of creation. And it could have, for example, a different maximum speed. So this is what we mean by an object of a class, where a class defines a blueprint or a template. So a class, as we've said, is a collection of variables and methods, where the methods define the behaviors or the operations, and the variables define what these entities can have operations performed on them. So here on the left-hand side is the syntax for defining a class in Python, and on the right-hand side is an example of defining two classes and then creating objects of those classes. So we'll start with the syntax of a class, of defining a class. So the first thing that we have to type is class, and then we give whatever name that we want for that class, and then we open and close parentheses, and we end that statement with a colon. So inside the class, we can define as many methods as we want. This first method here is a special method. This method is Python's version of a constructor. So if you remember constructor in Java, it is the method that is being called when we create an object. And the point of this method being called is that we decide what are the initial values that we want for the object. So in Python, it is the same thing. We have to type it in this same form. We started with a double underscore, we type in it, and then we end it with a double underscore. It has to be typed this way. We can't type it any other way. You can't just write in it. You can't just write a single underscore at the beginning and a single underscore at the end. It has to be double underscore in it, double underscore. Otherwise, it's not going to behave as a constructor. So you have to be very careful with this. I've seen many students make this mistake where they only add a single underscore at the beginning and end, and then they complain, why is it not working as constructor? So you have to be very careful. So what is inside, what are the arguments in this method that is called init? Well, it has as many arguments as you need. So it depends on how many values do you want to initialize. And we have a special variable at the beginning, which is called self. This variable has to be the first argument of any instance method. And what it means, this self variable, it means that it is this instant or the current instance that we're dealing with. So in Java terms, it is similar to this dot whatever variable that you want. So in the same sense, we use self, and it'll be more clear in the example. So then inside this method, we can write as many statements as we want. These statements are usually initializing of variables. And then in other methods, again, we always start with, if it's an instance method, it always starts with self, and then if we have any more arguments, we can type them, and then we can execute as many statements as we want. So now we look at the example. In the example, we created two classes, and then we created objects of those classes. So the first class is an ID generator. So the point of this class is that we want to generate some IDs. So at line 3, we have a constructor, and we type init with two underscores at the beginning and end, and we always have a parameter self. So because we don't have any other parameters, that means from the main, we don't expect any value to be used to initialize a value in this ID generator. And by default, the ID is initialized with 0. So self.id means that this current instance or this current object will have an ID, and this ID is equal to 0. And then we defined another method called generate, and as we said, because it's an instance method, we have to have as the first argument self. In this case, the first argument is the only argument. And then self.id is equal to id plus 1, self.id plus 1, meaning that we're incrementing the ID that we've initialized. And then we return this self.id. We created another class at line 9, and this class is called ID, and then we have this constructor. So when we create an object of an employee, during the creation of this object, we have to pass a name and an ID generator as arguments. And then we have a variable in the employee class that is called ID, and this ID will be ID underscore gen dot generate. So it is this ID gen is an object of this class, and we will call its method generate. So by default, this value is 0, and then when we call the method generate, it will increment it. And then the self.name, it'll be equal to name. So as I said, self is similar to this dot name is equal to name in Java terms. So self.name is equal to the name that is added as an argument. Self.did is equal to none. We don't have a default value for it. And then self.salary is equal to none, meaning that we have a salary and we have a DID, but we don't want to initialize them for now with any. And then we have another method, print details, and because it's an instance method, we also have to include self, and then we will print the details of an employee. We will print their ID, their name, and their salary. So here, in this example, we want to access the ID, we have to access it through self. So we write self.id, self.name, and self.salary. So these are the two classes. Now in line 24, we create an object of idgen, which is equal to ID generator. And this will create an object called idgen. At the beginning, the ID, it only has one instance variable, which is ID, and this value is equal to 0. And now we create an object of the employee class, and we call it employee1. we pass two arguments, imp1, which is the name, and we pass the ID generator as a second argument. And then employee1, we add the salary. So we didn't add this value as part of the constructor, we added it then afterwards, and it became 20,000. And then the employee DID is equal to 2, and then we created another object called employee2, we gave it a name, employee2, and we passed the same ID generator. So now the increment will be, instead of, this was at the beginning, the ID was 0. With this being called, because we call gen.generate, it will become 1, and then in this call it will become 2. And we gave them a salary, and then we gave them a d.id, and then when we print the details, it will print the details for the first employee, the second employee will print the details, and it will print the details of the second employee. So in Arabic, بالعربي هنا في ال left hand side نشوف تعريف الكلاس. فأول شيء كتبنا كلمة class، بعدين نختار أي اسم class نبغاه، نحط أقواس، وبعدها نحط الكولن، بعدين نعرف على عدد الميثودز اللي نبغى نعرفها. طيب الميثود اللي تقابل فكرة الكونستراكتور في الجافا اسمها في البايثون init، ولازم نكتبها بهذه الطريقة، لازم نحط دبل أندرسكور في البداية ودبل أندرسكور في النهاية. إذا ما كتبناها بهذه الطريقة ما راح يتعامل معاها ككونستراكتور، راح يتعامل معاها as any other method. فعلشان نبغاها يعاملها ككونستراكتور لازم نكتبها بهذا الشكل، دبل أندرسكور init بعدين دبل أندرسكور. طيب بعدين نعطيها عدد الارجيومنتس اللي نبغاه. الفيرست argument دائما لازم تكون self. ايش معنى self؟ self معناها الcurrent instance، يعني الcurrent object اللي احنا قاعدين نتعامل معاه. فهذا الcurrent object هو راح يكون فيه كل الفاريبلز المتعلقة في هذا الobject. فلما في البايثون لما ابغى اسوي access لاي variable متعلق بالobject هذا لازم اكتب self بعدين اسم هذا الفاريبل، بعدين اقدر احط عدد الارجيومنتس اللي انا احتاجها. عرفنا هنا another method، هذه الميثود ايضا نوعها instance method، فلازم اول argument يكون الself اللي هو الobject عشان اقدر اتعامل معه. بعدين اقدر احط as many arguments as I need، اذا احتجت اكثر اضفت اكثر، وداخلها راح يكون عندي مجموعة statements. هذا الإكزامبل عرفنا two classes. الكلاس الأول الهدف من هذا الكلاس إنه يسوي لي generate الIDs، هذا الهدف منه. عرفت فيها two methods، الميثود الأولى هي الكونستراكتور، بس أعطيتها self، معنى إني أنا الحين أعطيتها هذا الأوبجكت، واللي راح أسويه إنه ما أعطيتها arguments، فمعناتها من المين ما راح أسوي call أي value وبعدين راح أعطيها قيمة بناء على هذه الفاليو اللي جتني من المين، لا، أعطيتها أنا قيمة ابتدائية تساوي 0. فهنا عرفت variable اسمه ID، وهذا ال ID تابع لهذا ال object اللي اسمه self، وقلنا self.id تساوي 0. بعدين عرفنا method ثانية، هذه الميثود سميناها generate، أيضا نعطيها self، معناها إنه إحنا قاعدين نتعامل مع هذا ال object. طيب عشان أسوي access لهذا ال ID لازم أقول self.id، وبما أنه generate يعني بيسوي لي ID جديد، فالهدف منه إنه أنا أزيد قيمة ال ID بواحد. هنا قلنا self.id هي تساوي قيمة self.id plus 1. بعدين أبغاك تسوي لي return self.id عشان يعطيني قيمة ال ID الجديدة. فطريقة التعامل مع ال variables في البايثون تختلف شوي عن طريقتها في الجافا. في الجافا كنا نعرف ال variables قبل ما نعرف ال functions، نكتبها في البداية بعدين نتعامل معها. في البايثون غالبا نكتب ال variables اللي نبغى نعرفها داخل الميثود الخاصة بالinit. هنا نكتب self.id self. أي عدد variables نبغى نعرفها، عادة يكون تعريفها في الinit، وبعدين نتعامل معاها. ما أقدر أتعامل معاها بشكل دايركت ما نقدر نتعامل معها بس نكتب ID على أساس أغير قيمة ID، لازم أكتبها من خلال كتابة أول شيء self.id self. اسم الفاريبل الثاني. فهذا بالنسبة لي الفيرست كلاس. السكند كلاس اللي هو اسمه employee فيها two methods again. الميثود الأولى اللي هي الانيشاليزر أو الكونستراكتور، أخذنا من المين قيمتين اللي هي النيم والاي دي جن. النيم معناها باخذ اسم لهذا الامبلوي. الاي دي جن الفكرة منها والهدف منها انه انا ابغى اعرف وين وصل العداد، لان هنا احنا عرفنا اوبجكت من الاي دي جنريتور، وابغى اعرف هذا الاوبجكت وين وصل العداد فيه عشان كل امبلوي يصير تابعين لنفس العداد، او على الاقل الامبلويز مثلا في نفس القسم او في نفس الشركة يكون لهم عداد واحد من 0 إلى أو من 1 إلى رقم معين. فأنا أبغى أرسل له هذا العداد. فقلنا self.id لهذا الموظف راح يساوي id gen اللي هي we pass this as an argument اللي هي object من first class dot generate عشان يعطيني value جديدة عشان يكمل العداد. بعدين self.name راح يكون النيم اللي أرسل لي إياه. self.d_id هنا معناها أن أنا أبغى أعرف variable، لكن حاليا ما أبغى أعطيها قيمة مبدئية، بعدين ممكن أنا أغير هذه القيمة أو أعطيها قيمة مبدئية. وبعدين أبغى أعرف another variable، وهذه الفاريبل اسمها salary، أبغى حاليا أعطيها قيمة مبدئية، بعدين أنا بحط لها قيمة أو بضيف لها قيمة. فهذا بالنسبة لي الكونستراكتور. السكند فانكشن هو عبارة عن فانكشن بسيطة بس تطبع التفاصيل، فراح تطبع الاي دي، تطبع النيم، وتطبع السالري لهذا الموظف. فهنا عرفنا في لاين 24 طلعنا من الكلاسز، عرفنا ان ID gen object من ID generator. فمبدئيا كان عندي الاي دي، صار عندي variable اسمه ID وقيمتها المبدئية هي 0. بعدين عرفت an object of employee سميته employee 1 وأعطيته قيمة employee 1، فهذا راح يكون النيم. والاي دي جن اللي هو الاي دي جنريتور أرسلت له هذا الأوبجكت. والحين راح يكون الاي دي جن دوت جنريت، فراح تزيد هذه قيمة الاي دي ب1، والنيم راح يكون النيم اللي أرسل لي إياه. الدي أندرسكور اي دي ما راح تكون لها قيمة مبدئية. السالري ما راح تكون لها قيمة مبدئية لأن أعطيتها قيم تساوي نل. بعدين هنا أعطيت قيمة مبدئية للسالري تساوي 20,000 وأعطيت الدي اي دي تساوي 2. again سوينا نفس الخطوات الامبلوي 2. فالاي دي جن بما أنه هو نفس الأوبجكت، فلما سويت لها كول من هذه الميثود فهي راح تزيد العداد ب1، فكان العداد الاي دي كان 1 راح يكون الآن 2، وراح ترسل قيمتها بما أنه سوينا ريتيرن للاي دي هنا راح يكون قيمتها 2. ونفس الخطوات مع السالري والدي اي دي، طبعنا القيم لإمب 1 وإمبلوي 2، راح تطبع لي الديتيلز for these two employees. فالاختلاف في البايثون مقابل الجافا إنه أولاً الكونستراكتور طريقة كتابتها، وثانياً إنه راح نكتب self. ثالثاً الفاريبلز بنعرفها خارج نطاق الفانكشنز. إذا كانت instance variables نعرفها داخل عادة الانيشاليزر أو اللي هو الكونستراكتور. So now detailing the code, we've already discussed the ID generator. I've said that this is a class, and we've discussed the method inside. I'm going to discuss this again because it's important. The init method is the constructor in Python. In other programming languages such as Java, we're used to having the constructor the same name as the name of the class, but in Python it is written by this syntax: double underscore init and then double underscore. So we can either declare it explicitly if we have values to be initialized, or if we don't declare it explicitly, then an implicit constructor will be created. And we have to always pass the self argument. So what is the self argument? Again, the self argument represents the current instance of the class. Every method that is a instance method not a class method, an instance method, meaning a method that belongs to an object, it must have self as its first argument, because self means the current instance or means the current object. So this applies to all methods and also the constructor. So it should be noted that when we invoke this method, we don't need to explicitly pass the self. This will be handled implicitly by Python. So what that means, that line meant, is that we need to define self when we define those methods. So we have to write self here and self here. And for example, we have to write self here and self here. But when we call the methods, we don't need to explicitly type self as one of the arguments. So here we just wrote the name and the ID generator. We didn't write self. So this is what it means by that line, that it's going to be implicitly handled by Python. Okay, so any self-level variable has to be declared with the self keyword. We always have to start with self dot and then the name of the instance variable. We can't just use it directly. We can't just type D, capital letter D underscore ID, name, ID, salary. We have to start it with self. Self, the word in itself can be any word. It doesn't have to be self as a keyword, but it's almost considered as a keyword. So it's not technically, you can choose any word, but it is almost used as a keyword. That's how popular the use of the word self is. So this can be seen as in the constructor, we have declared the instance variable's ID as self.id. We didn't write ID directly. And then the rest is repetition of what we said. So you can read this on your own. So class relationships. Now we're going to start discussing the relationships between different classes. So one of the greatest advantages of using object-oriented programming as a programming paradigm is code reuse. So because in OOP it supports relationship between classes, we don't have to rewrite code that already exists in a different class. So for example, if we have two different classes that both need the same function, we can write it in one of them, and then depending on the relationship, we don't have to rewrite that code again. So we can just, by the definition of the relationship, reuse that code. So we'll see that when we discuss the different types of relationship. So in object-oriented programming, we generally have 4 types of relationship, and we will go through them one by one. We will start with inheritance, and then association, composition, and finally aggregation. So in class inheritance, it means that we have a hierarchy of classes. One class is usually a parent class, and another class is a child class, where the child class inherits all of the variables and the methods of the parent class. So class inheritance is a feature that can use to extend the functionality of a class by reusing the capability of another class. So as an example, if we have a class called car that contains general attributes of a vehicle, which is also another class. For example, the vehicle has a category, has a mileage, has a capacity, has a brand. So the car, we don't have to recreate or rewrite variables for those for variables. We can just inherit them from the parent class, which is vehicle. So here it gave an example. If we have a class that is a Ferrari, which is a type of car, then it can extend all of the variables and methods of any regular car with additional characteristics specific for a sports car, such as horsepower, top speed, acceleration, and power outlet. So the type of relationship, if we define it in words, it is an is-our relationship. So a Ferrari is a car is a vehicle. So the type of relationship is an is-out relationship between the child and the parent class, or we can also call it a base class. So here we have an example of an inheritance relationship, and because it's not very clear, I'm going to show it to you on my Python code. So the first 19 lines is the same code that we've used in the previous example. So the first class we've created an ID generator, and then the second class we created a class for an employee. So here's the new part. We created a class, we called it programmer, and then we want the programmer to be a employee, meaning we want to create an inheritance relationship between the employee and the programmer, where the programmer is the subclass or the child class and the employee is the parent class. So the way that we do this is just by adding the name of the parent class between the parentheses of the subclass. So here the subclass, we write class when we define it, the name of the class, and then between the parentheses we decide what is the parent class. And that's it. Simple. So here we have the constructor of the subclass, and as we've said before, the first argument is going to be self, meaning the current instance, and then name and ID generator, because we've already have these two arguments in our parent class, and then we can add extra for this child class. So we've added the lang, meaning the languages that they know, DB, the databases that they know, projects, the project that they worked on, because it's a programmer at the end of the day, and then add skills, meaning any extra skills that they have. And we've added the double asterisk, which means that it is keyworded and we can have an unlimited number of skills. So now for this object, we've added to a variable belongs to this object called languages, and the value of languages is now the value coming from the argument. And we've also defined the databases is equal to DB, the project is equal to the project that we get as an argument, and the skills is also the skills that we get from an argument. And then finally here at line 29, this means that we're going to call the super, meaning the parent class, and we're going to call the init method. So from the super class or the parent class, we're going to call the init method, and we'll pass these two arguments, which is the name and the ID generator, so that these values are going to be initialized by the values that we have as an argument. And we've also created another function or another method, and this will print all of the details of a programmer, including their skills. So again, because ID and name and salary all belong to an object, so we have to include self.id, self.name, self.salary. We cannot write them directly without the self. And then for the languages, because we expect it to be in a list, then we'll have to go through a for loop that goes through every element in the list, and it will print them between tabs. The same thing goes for the databases. And then finally the skills, because it's keyworded, so we handle them the way that we handle dictionaries. So we'll have for key and value in self.add skills.items, because that is how we handle a key and a value. And we will print between tabs the keys, and then for each skill in the values we will print that skill. So now we defined a generator, an ID generator, because we want to generate IDs, and we created an object of a programmer. And the first argument is the name, and then the second argument is the object that will generate for us the IDs, and then the third element is the languages, which is in a list, and then the fourth element is the list of databases that they know, and then the list of projects, and then the list of operating systems, NoSQL databases, and data science. So because we have add skills, all of these are the extra skills that they have. So up until here, these are the keyworded extra skills that they have. So now if you print skill details, and this is example 2. Wait a second. Oh. Okay, so it will print the ID, the name, and then because we didn't define any salary, it will just print none. And then the languages, it'll define all of the languages that we know. So now we're at this line. For L in languages, it will print a tab and then the language. And because print has implicitly goes by to a next line, so this is a tab and then it prints the language, and then it goes to another line and then it prints tab and then the language, another line, and so on and so forth. And the same goes for the databases. And then the extra skills, the key here is OS, NoSQL, and data science. And the values are these lists. So that is why we have a double for loop, because here we have the OS, and then inside we will have the different versions of OS that we know. And then again, for this for loop, it will go through the second item, which is NoSQL, and then the skills, which is the number of NoSQL versions that we know. And same goes for data science. So that is why it is a multi-level for loop. So I hope this is clear. Just a single note, or 2 notes I would like to mention, is that the init function, we have this super method. So in Java, if you have previous experience in Java, we know that the call to the super methods, the super classes constructor is usually the first line. And if we don't write it, it will be implicit. In Python, it is never implicit. You have to write it explicitly if you want to call the parent class's constructor. So that is the first thing. The second thing, it can be at the end. It doesn't have to be the first statement. You can have it at the first statement, the last statement. It is up to you. So these are 2 important notes. That it has to be called explicitly, and the second note that it can be at the beginning, it can be at the end of the constructor of the subclass. It doesn't have to be the first line. So now back to the slides. So this explains what we've just said. You can read it on your own. And now we'll move on to access modifiers. So in Python, we don't have access modifiers in the same way that we do in C++ and Java. In C++ and Java, we have 3 main access modifiers. We have public, protected, and private. So public means that it can be accessed from anywhere. Protected, only accessed by the class and its subclasses. Private can only be accessed by that class. So in Python, we don't have the same meaning of access modifiers as it is in Java and C++, where they are enforced in code. But we have a partial workaround, and we'll see it. But this workaround can only be used to indicate that this variable is meant to be public, protected, and private. It doesn't really enforce it, but it tells you that this was meant to be public, protected, or private. So the word indicate is important here because Python doesn't prevent the usage of protected or private members. It just indicates which members are which. So another programmer should respect that this is meant to be public, private, protected, but you cannot enforce it in Python code. And we'll see this in an example. So here we define 2 classes. The first class is ASP_parent, and then another class which is a child of this class called ASP child. So in this parent class, we have three variables and we define them in the constructor. The first variable is called public, the second variable is called underscore protected, and the third variable is called double underscore private. So the way that we write or indicate that this variable is public is just by writing the name. And the way that we indicate that a variable is protected is by having a leading underscore. And the way that we indicate that this variable is meant to be private by adding a leading double underscore. So this variable is public, this is protected, and then this is private. So here we define the child class, and it has two methods. The first method being the constructor, and it doesn't do anything, it just passes the values from the object creation to public, protected, and private. So it passes them to the parent class. And then we have another method, and this method is called print members. The point of this method is that we want to see whether it's true that we cannot have access to private variables from outside a class where it's defined. A protected variable can only be accessed by subclasses and parent, and that a public variable can be accessed anywhere. So we did a try and catch, or in Python syntax, try and except, and we printed out the self.public, self._protected, and self._private. And we'll handle any exceptions if we find any. And then we'll discuss about line 19 later. Here we created an object of the ASP child, and we passed three values, 1, 2, and 3. 1 will be stored in public, 2 will be stored in protected, and 3 will be stored in private. And then we called the method print members by using the object, and then we'll see what happens when we call this method. So first, when we call this method, we will be on line 13. Public is, and it should try to print the public variable, and it is printed. And then it tries to print the protected variable. Again, it is printed, and this is expected because a protected variable should be accessed from the class itself and any of its subclasses. And then we're trying to access the private variable, and we get an exception here. But is it because that we cannot have access to private variables? No. It is because Python, the way that it defines private variables to be accessed from outside of the class, is having this syntax. So whenever we want to access a private variable from a different class, we have to use the following syntax. We start with an underscore, and then we write the name of the class that this private variable belongs to, which in this case is ASP_parent, and then we write the name of the variable, and it can be accessed from anywhere. So now when we handle this exception and we print it out, private is, and then we use the correct syntax, the value of private was printed out. So in Python, there is no way to enforce that this should be protected, this should be private, but it indicates to other programmers that this was meant, because it doesn't have any leading underscores, this is meant to be public, and if it has a single leading underscore, it means that it's protected, and if it has a double leading underscore, it was meant to be private. So now we try again by calling it from the main, and from the main, in other programming languages, we can only access the public variables and the public methods. It shouldn't have access to protected variables, it shouldn't have access to private variables. But now, we'll see what happens when we do call it, or do call these variables from the main. So it prints the public variable. Normally, it prints public outside, and it prints the variable. The protected variable, although it should only be accessed by the class itself and its subclasses, we did have access from the main, and the private variable also we had access to it from the main when we used the correct syntax, which is a leading underscore, the name of the class, and then double leading underscores for the name of the variable or the name of the method. ففي البايثون ما عندنا طريقة نقدر نسوي فيها enforcement إذا هذا الفاريبل أو هذا الميثود نبغاه يكون private, public or protected، لكن عندنا طريقة إنه نوضح other programmers اللي يشتغلون معانا إنه المقصد من هذا الفاريبل إنه يكون public، المقصد من هذا الفاريبل إنه يكون protected، المقصد من هذا الفاريبل إنه يكون private. لكن ما في طريقة في بايثون نقدر نجبر other programmers إنه يتبعون هذه الطريقة. فالprotected زي ما لاحظنا هنا قدرنا نسوي له access من خارج الكلاس نفسه أو السب كلاسز بطريقة مباشرة، كتبنا اسم الفاريبل. الprivate نقدر نسوي له access from outside of the class and outside of the يعني from the main or from its subclasses. لكن الفرق إنه في البرايفت ما نقدر نسوي له access مباشرة بهذا الشكل إلا من الكلاس نفسه. in other classes لازم نكتبها بهذا السنتكس. مو معناته إنه ما نقدر نسوي عليها access إلا نقدر، لكن لازم يكون بهذا السنتكس إن نكتب underscore اسم الكلاس بعدين double underscore اسم الفاريبل. فهنا نقطة مهمة. Again, however, there is nothing to prevent this member اللي هو اسمه underscore private from being used outside of the class. If they are to be accessed outside of the class, you must follow the specific convention. نكتب هنا اسم الانستنس dot underscore اسم الكلاس بعدين اسم الممبر. ففي هذه الحالة لما تعاملنا معها من المين this is the name of the instance dot underscore اسم الكلاس اسم الفاريبل. لما تعاملنا معها من السب كلاس اسم الانستنس في السب كلاس هي self بعدين dot underscore اسم الكلاس بعدين double underscore اسم الفاريبل. So it can be accessed حتى لو عرفناها كprivate. Another type of class relationships is composition. And composition in OOP represents the part of relationship between classes. So if I have two classes, one class is part of another class. So for example, a car and an engine. An engine is a part of a car. And another example, a book and a chapter. A chapter is a part of a book. So we can define these two classes such that one of them is part of the other. And in the coming example, we have a relationship between a Ferrari car class and an engine class. And the type of relationship is composition. And we'll see how we write that in code. So here in this example, we have a class called car, and we've seen this before. And then we have a class called Ferrari, which extends car. So the relationship between these two classes is inheritance. And in the constructor, we called the super constructor to pass the values for cat, mileage, and capacity. And it also has some extra variables specific to a Ferrari car, such as horsepower, top speed, and acceleration. And then here we print the details of the car. So now we defined another class called engine. And to say that this engine class is part of a Ferrari class, we will first describe the engine. So we will type whatever we need in this engine. It has a single variable called details, and at first it's initialized to none, and then when we call the details method, we will initialize the value for details to equal to this value, and then it returns the self-details. So to explain the relationship or to define the relationship between these two classes, that the relationship between them is composition and that a engine is part of a Ferrari, we can see here when we defined the print car details, we created an object of an engine. So we created an object of this class in this class. So this means that a engine is part of a Ferrari car. And it could be part of any car. But in this example, it assumed that it was part of a Ferrari car. So when we defined the engine, we used the variable engine.details to print the details of that engine. So what that means when we have composition is that the engine is part of the Ferrari. When we define an object of a Ferrari, it implicitly defines an object of an engine. And then when we delete this object of a Ferrari, it will delete the object of engine because it is part of this object. Well, here we created the object. It has all of the details. and then we called object.print card details. So now it should print whatever's in here. So first it prints the category, it prints the mileage, it prints the capacity, the horsepower, the top speed, and some details about the engine. So this is important to note here. In composition relationship, the object is created within the other class. So the engine class the object of an engine class was created inside the Ferrari class in a composition relationship. Now another type of relationship, which is association. So the association relationship, it has a relationship between objects of different classes. So these two objects that belong to different classes, they are associated with each other, but the kind of relationship is that they are independent of each other. So they have some relationship between them, but that relationship is not a part of relationship where one is part of the other, or an is a relationship where one inherits all of the features and all of the methods of the other. This means that we have two independent classes that has some form of relationship that is loosely coupled, and we call that association. So an association relationship, it can be one-to-one, and it also can be one-to-many. So one of the examples of an association relationship is between an employee and their department. So an employee has a department, and a department has employees. So this is an example of a relationship of association. It is not part of relationship because a department is not a part of an employee. You can have an employee without having a piece of them as a department, and a department, in terms of its construction, it doesn't include any employees. It has employees, but it's not part of the department. So let's see an example. So here we have an example of an association relationship using these classes. So we defined a class called department, and it has two methods, the constructor. So every department has a name, a location, and a method that will print the information about a department. We also have a manager class that defines the ID of a manager, the name of a manager, and we print the info of a manager. We also have information about an employee. They have a name, they have an ID gen, meaning that we generate an employee ID. So this is continuing the same example that we've been talking about the whole class. And then it has a department and it has a manager. So be careful here. So when we define these values, they're passed as arguments. So the department is passed as an argument, the manager is passed as an argument, because an employee has a manager, an employee has a department. This is the kind of relationship that we've defined here. So in composition, what we did is we didn't pass it as an argument, we created that object in the employee class. So for example, here in the car class or the Ferrari car class, we created the object of an engine. So what that means is this engine cannot be defined or cannot be independent of this Ferrari class object. It has to be a part of it. But here they are independent. We pass them as variables. Where did we define this department or this manager? We define them in the main, independently. So, and then we have a print detail that prints all of the details of the different values. So to refer to the department info, we will have to say self, meaning this object's department, which is this variable department that we have passed, and then dot department info to print the information of the department. And then again, self, because we're talking about this object's manager, and then we want to print this object's manager's manager info. So in the main, we define an ID gen to generate the IDs, and then we defined a manager that has an ID of 100 and the name of manager X. And then we defined a department, we called it the IT department, and the location is Delhi, and then we created an object of an employee. They have a name of employee 1, and this is their ID, and then we passed as arguments the manager and the department. So this shows the essence of association relationship. These two objects are not a part of the employee class, but they have a association with it. So if we delete this employee object, these two still exist. If we delete the manager, the employee still exists. They're not dependent on each other in the same way that we've seen in composition. And then we gave them a salary and we gave them a DID. So I hope this is clear, the difference between association and composition. Then lastly, we have aggregation relationship. So an aggregation relationship is a special kind of a has-a relationship that is always one way. So it's unidirectional. As an example, we have an employee and an address. So an employee has an address, but we can't say that an address has an employee. So it's unidirectional. An employee has an address, but an address, we cannot say that an address has an employee. It doesn't make sense. So the way that we define it is we created a class and we called it address. We sent in some arguments and we defined those variables such as the country, the state, the area, the street, the zip code, and a method for address information. We also created an employee object and we passed as an argument the address. And then we printed the details. So again, we have all of these relationships and then we have this address. So it tells us the address of a certain employee and we pass that as an argument. So the only difference between association and aggregation is that aggregation is unidirectional. It is only one direction, so an employee can be passed to an address can be passed to an employee, but it cannot be two-way relationship. And then we add some information about the salary, the DID, and we printed the details. So the final topic of today's lecture is abstract classes. And if you remember from your Java course, abstract classes is a class that we cannot create any objects from. So if we want to create a class that we cannot create objects from, we define it as abstract. So an abstract base class, popularly known as an ABC class, is a class that typically contains abstract methods. So an abstract method is a method that we force the subclass to implement, meaning that it typically doesn't have an implementation, but it's simply used to declare that this must be implemented in all of the subclasses. So we'll look at the notes after reading the code, so I'll just move to the code. So in Python, it's a little bit different from other object-oriented programming languages in the sense that abstract classes are not built in the language. We have to import them from an ABC module, and we will import the ABC class and abstract method. So now we want to define this class as an abstract class. The way that we define this class as an abstract class, we give it a name, and then it inherits from ABC. And that means that this class is an abstract class. That means that we cannot create any objects from this class. And then we defined four methods. The first method is the constructor, and because this is a queue, if you remember from the data structure course, it means that it has a buffer or it has a memory location. And in Python, we define it in the sense of a list. So in the initializer, we create a buffer that includes an empty list, and we also create a concrete method. So an abstract class can have abstract method, and it also can have concrete methods. But we define it as abstract, meaning we cannot create an object of this class. So this method is concrete because it has implementation, and this method is abstract. And what it also means is that we must implement these two methods in any subclass. So in the print item methods, the point of this method is to print all of the items in the buffer. And then here we defined two abstract classes, enqueue and dequeue. And the way that we know that this class is defined as abstract is because we have an abstract method decorator before it. So this is the syntax for writing that this method below is going to be an abstract method. We start with an @ and then we write abstract method. And then here in this method that is enqueue, because we add items in this list, then we'll have to include self and also items, or item, single item. And then because we don't want to implement it, we don't have any default implementation, we just add pass, meaning that this will be implemented later when we create subclasses. And we also have another method called dequeue, and this is typically the method that we use in data structures to delete some elements. So we don't have to get any other argument other than self. So now we're defining a class called queue, which is a subclass of this class. And that means, because it's a subclass of this class, that means it has to have a concrete implementation of these two methods. Otherwise, we're going to get an error. We cannot create objects of queue. So the queue class inherits from queueAbs, and we defined a constructor. The first line of this constructor is we call the superclasses constructor. So we have now a buffer, which is empty, and we also have a variable called self.length, and this length means how long can this buffer have as a maximum value. And then we created the implementation of the enqueue, the abstract method, and we use the same arguments, self and item. And first, before we add any items in the queue, we have to check, is it full or is it not full? And we know that it's full if the length that we've defined here, when we create an object of queue, so for example, let's say that we want a maximum of 5 elements. So if I find that the buffer includes, if the buffer has less than or equal to the number of elements, then that means that it's full. And if it's full, then we will print that the queue is full, and we will return without appending that element. Otherwise, we will append that element. And we write it using this syntax because self meaning this object, and then this object has a variable called buffer, and this buffer, because it is a list, then we will have to add items by including the append method, and then we include that item. And then dequeue, the opposite operation, is to remove elements. We have to first check before we remove that if it's empty or not. So we check if the length of the buffer is equal to 0, meaning it is empty, then we cannot remove any elements because it's an empty queue. Otherwise, we'll get the first element, which is buffer at index 0, and we will store it in a variable called element, and then we will delete that element, and then we'll return that element for whatever purpose that we want. We might want to print it when we delete it, so this gives us a chance to do that. Then we defined a third class, and this class is a driver class, and we defined a main method there, and in the main method we created an object of queue, and we gave the length of the buffer to 10. So this is the maximum number of elements in the buffer. And then we printed enqueuing, and then we added items into the queue. So we started from index 0 to 1, and we added those items. So we added item 1, item 0, 2, 1, 2, 3, up until 9. And then to print those elements, we used the object queue.print items, and this print item is not in the queue class. So because it's not in the queue class, it means that it will look for it in its parent class, and it is here in the parent class print items. And it's a concrete method, so it can use it directly. And then dequeuing, the opposite operation, for every element in the range of 0 to 10, we will dequeue the elements one by one, and it will print those elements. Then to run this code, we have to create an object of the driver class and then run the method by using the object d.main. So this is how it looks like. We first start with printing enqueuing, and then it will print every item, because here we print them one by one, and then we continue with dequeuing, and then it will print every item that it dequeued, so from 0 to 9. So if we don't implement this method, for example, which was defined as abstract, we can no longer create objects from the Q class. So now we'll get an error because the dequeue method has not been implemented. So we have to implement all of the abstract methods for the class to be, so that we can be able to create objects of this class. So now we can go back to the notes. For a few important pointers, the abstract method in Python is declared with the abstract method decorator. We have to start it with an @ and then write abstract method before in the line before the method declaration. While abstract class can contain abstract methods, nothing prevents an abstract class from having normal non-abstract methods, which we've already seen here. So this abstract class included normal classes, or we also call them concrete classes, and it also included abstract classes. It doesn't have to only be abstract classes. And an abstract class cannot be instantiated. We cannot create objects from that class. A subclass of an abstract class must implement all the abstract methods of the base class, as we've seen just a few minutes ago. So an abstract class in Python are implemented using the ABC module. We always have to include ABC module, and we import the ABC and the ABC abstract method. So all of this we've already covered, and this concludes our lecture.